Section 9.1, Inferences for Regression, video number 3. So, let's estimate the slope of the population regression, beta 1. Just like every other confidence interval we have ever seen, this confidence interval has 4 steps. Find the z or t, in this case it's t. Find the standard error, this will be handed to you in the computer output. Multiply them to make the margin of error, and then add or subtract it to the point estimate for the population value that we're estimating. In other words, add or subtract the margin of error to the sample version of the population value that we're estimating. So let's go back to the printing speed and pages per minute versus price model from the computer output from the previous video, and let's estimate the slope of the population line based on that output. This is straight out of the book. It's on page 579. Excuse me. One thing I neglected to mention is since we are going to be using the t statistic in our confidence interval, we will need the measurements for the degrees of freedom. The measurement for the degrees of freedom is n minus 2. N is the number of points in the scatter plot. Basically, we lose 1 degree of freedom for each variable for the response in the explanatory. All right, so let's do standard confidence interval protocol. Number 1, find the t. Now, nowhere in the previous video did I mention how many ordered pairs there were in the computer output that was provided to us, nor was there any evidence in the computer output that would allow you to deduce the number of ordered pairs there were. However, excuse me, back on page 577, they did list all the ordered pairs, and there were 20 of them. So we had n equals 20. This implies that the degrees of freedom is 18. So if we were to do our standard approach for finding the value of t, excuse me, I'm missing something sort of important here. You know what it is? It's the confidence level. So let's estimate this at, I'll use the same confidence level they used. I'm going to guess it's 95, and it is at 95% confidence. Actually, before I go any further, I invite you to pause the video and see if you can complete the confidence interval. You may need to go to the previous video to get some of the values, or if you have your book, the computer output is on page 577. It's also on page 579, but the problem is already worked out there, and that would kind of give it all away. So pause the video if you like, and see if you can complete the confidence interval. All right, either you paused it or you haven't. Either way, I'm moving forward. Have my handy t-chart here. So for 18 degrees of freedom, well, we got to figure out the percent in each tail, but I think you all know by now what it's going to be. The confidence level represents the middle area. The remaining 5% gets divided into the 2 tails. So 2.5% in each tail. And so using our t-chart, 2.5% in the right tail, 18 degrees of freedom, 2.101. If you're following along on page 579, you'll notice that they only use 2.10. Of course, I'm going to use what my chart gave me. Second step is to find the standard error. And up until now, this has been a value that we've calculated based on a formula. But now it's just given. Do you remember where I told you the standard error was in the computer output? It's under the standard error column, go figure. In the explanatory variable row, the second row. And so our standard error was 19.49. Next step in the confidence interval is to find the margin of error. And even though I didn't give you the formula for it, you should know by now it's the product of the first 2 values, the t times the standard error. So our margin of error is going to be 2.101 times 19.49. Let's take this to, well, let's think about this for a second. We're estimating slope. The slope is measuring the change in printing speed versus the price. So we should probably think of this in terms of money. So I'm going to round this answer to 2 decimal places. Actually, scratch that. Without any context, the default would be to round it to 4 decimal places. So I'm going to continue with that unless I state specifically otherwise in a given problem. 40.9485 is our margin of error. And so our last move is to actually find the interval. So the sample version of the population value we're estimating, plus or minus the margin of error. So B1 plus or minus the margin of error. Now, where do we get B1? In other words, the slope of the sample regression. We get that from our computer output. Under the coefficients column, which is what the second column should have been labeled, in the second row, we have 90.88. Plus or minus the margin of error. I'm going to move it up here. So if we find the difference, 90.88 minus 40.9485 is 49.9315. And if we find the sum, oh, that's not right. The sum is 819,019. I don't think so. I think I forgot to type the decimal. 131.8285. So as a confidence interval, there's my answer. But remember, we're estimating a slope and we can interpret a slope. Remember, the interpretation of the slope is for every increase in 1 in the explanatory value, we predict the response variable to increase or decrease by this amount. So how can I interpret this slope? So we'll interpret this. If the printing speed increases, let's actually write printing speed. If the printing speed increases 1 page per minute, we predict the average price to increase because our interval is positive, so we're estimating a positive slope, between, and since we're talking price, now I'll take it down to 2 decimal places, $49.93 and $131.83. That's a big range of values. This printer prints 10 pages per minute. I need one that can print 11 pages per minute. Okay, you can expect your price to increase somewhere between $49.93 and $131.83. Again, there are people working in the building, doing some maintenance and some housekeeping. Keep the building nice and sanitized and coronavirus free. So I will let them go about their business. Wow, that's a wide range. Is there any way we could tighten that range? Well, we could have a smaller confidence level, which would make a smaller t-value, a smaller margin of error, and therefore a smaller interval. Or we could increase, what could we increase? Well, we either decrease the t or decrease the standard error. And in order to decrease the standard error, you would need a larger sample size. I know that's not evident from the fact that they just gave you the standard error, but a general rule of thumb is the bigger the sample, the smaller the standard error. And so if we wanted to tighten this up, we would need more than 20 printers, speeds, and prices, and then we could get a tighter interval.